So we have the second talk today by Dr. Jan Holler. So Dr. Holler is a research fellow at the Ericsson Research, and he has been in Ericsson driving its technology and research strategies, especially in the Internet of Things domain. And he has been contributing to various European Union projects like Sensei, IoTi, and CityPulse. So he has been a co-author of the book Internet of Things, Technologies and Applications for a New Age of Intelligence. So he has been in the strategic product management, technology management, and various other divisions of Ericsson Research. So he has served for many years in the board of directors at the ISP Alliance, the first IoT alliance formed in 2008. So he currently also serves on the board of directors of the Open Mobile Alliance and is a co-chair of the Networking Task Group in the Industrial Internet Consortium. So without any further ado, I would invite Dr. Holler for the talk. Thank you.
I will just try to get my computer up and running. So let's see. So thank you very much for the introduction, and also thank you, Rajiv, for inviting me to come here and talk. This is my first time in India, I could say, and it is really a pleasure to be here. I also want to thank Rohit, Anand, and also Rajiv for helping me out, because when I arrived, opened my laptop, it was broke. So I had to go to the Ericsson office here in Bangalore and get some support to get things done so I could actually prepare my presentation. What I'm going to talk about is IoT, and that it's time to move to what we call hyperscale. So I will talk a little bit about what I mean by hyperscale, and then I will also talk about some of the different topics that we are addressing at Ericsson in solving some of the scale-related challenges. You already heard some introduction, but I'm new to the audience, so this is one slide that summarizes 40 years of my professional life. I'm not educated for my work. I'm actually a physicist by origin. I did research studies in theoretical nuclear physics. And then I realized that this is a discipline that had its peak in the early 60s. So I decided to not pursue an academic career, and I switched to industry. And I've been with Ericsson for 29 years. It's a great company to work in. As you can see, I've been doing much of the stuff. I worked the first 10 years in the product unit side, and the latest 20 years in Ericsson Research, working on all sorts of different things that does not relate to the core business at the point in time when I worked. So always trying to push the boundaries into new areas, working on stuff like SMDS and frame relay, and somebody might have heard of ATM. Usually it's related to banking today, but it was actually a technology that was very hyped many years ago. I worked in IP multimedia, in 3G systems, that became IMS and so on. And then in around 2004, we started working on wireless sensor networks and networked embedded systems. And that was my journey into the IoT space. So I've been working on all sorts of different topics around IoT, as you can see. And that basically summarizes who I am. Personal, I'm an outdoor man. Anything that has to do with outdoor, fly fishing, biking, hiking, whatever, I do that. And skiing, as you can see. Now, Ericsson, I should perhaps mention something about Ericsson as well. I cannot switch. Ericsson Research, the research organization. We have a corporate function with about 750 researchers. We are now established in 11 countries. The latest addition was Istanbul. We have 2 sites here in India, one in Chennai and one here in Bangalore. We are about 50% PhDs. We are engaged in over 50% of all the patents that Ericsson is actually producing. And the licensing incomes from the patents by a factor of, let's say, 4 or 5 or 6 outmatches the cost of running Ericsson Research. So we are a self-sustaining unit. And I should also mention that we are actually recruiting now in Chennai and in Bangalore. We're building up what we call Gaia, which is a global AI accelerator. So we're recruiting people on AI, and I think that in the demo area you can see, you can meet some of the people that we have. So that was a short introduction to how, who we are, who I am, and who we are. And I noticed that there are some nice connections to the previous keynote. Thank you for that. We will start with the Gartner hype cycle. I'm using it to point out that IoT is not at the peak. It has already passed the peak. Venture capital has moved away from IoT. Some people say that IoT, oh, it's a failure, it's no longer in existence. But in fact, what is happening is that we are, going down into this valley of disillusionment. And this means that people are actually now doing the real investments in IoT to transform industries and so on. And then that means that we need to target scale. So anything that has to do with proof of concepts that you do when you're on the way up or on the peak, that was yesterday. So forget about proof of concept. Now it is actually to scale. And that is what I'm going to talk about. So what do we mean by scale? The first thing that I want to talk about briefly is, what is at stake? How big is IoT? And I've been using this report from McKinsey many times in presentation that shows the economic impact or potential that IoT has. As you can see, it's about 10% of the global GDP. And that's a significant impact that it can have. Now, this is, of course, not the value of software or networking or ICT type of solutions, but it's the economic impact that it has. So scale in terms of value is huge. And also, if you look at the different sectors that are affected, there is no single sector in the economy or in society that cannot benefit from IoT. So there's a great diversity here in terms of different industry sectors and so on. And there are numerous of use cases, and I will get back to that towards the end. At Ericsson, usually, we are a networking and a mobile infrastructure company. We measure things in the number of connections. So, it took us about 100 years to connect 1 billion places using bakelite phones, if anybody knows what that is. It took us about 25 years to connect 5 billion people using cellular technology. And now we're looking at connecting the rest of the real world, and that is really IoT. So here you see some projections that we have in the Ericsson Mobility Report. In 2023, that's 4 years out, 4 to 5 years out, over 30 billion connected things, including mobiles. But the majority of that is actually IoT, so 20 billion IoT connected devices. Not all of them using cellular technology. There are other technologies in use as well. So the number of connections is going to grow exponentially. Another way, the connections, from Ericsson, we usually say that, IoT is happening because of the connectivity that we have been part of building. But I would say also that it's also thanks to the evolution of embedded computing. If you look at, in the past, companies like Intel, they have been focusing on, higher clock speeds, multi-core processor architectures, etc., just to, scale upwards. But in the last 5 years, it has been a much focus on actually scaling down. So lower power, decent compute power, decent storage capabilities, but reduced power consumption and much cheaper devices. And ARM, that is one of the absolute, leading companies in this space. You can see the evolution that they've had. It took them 22 years to ship 50 billion ARM chips. In 4 years, they shipped another 50 billion, and in the coming 4 years, they will be shipping 100 billion more embedded computing, so microcontrollers. And the majority of them will actually be networked. So this is another aspect of scale, and you can see the tiny speck on the golf ball there. That is a 32-bit microcontroller that is capable of hosting a web server. So this is what we are looking at, connecting the web in IoT. So scale, what does scale mean in IoT? We can talk about scale in terms of numbers, the quantitative aspects, like the number of devices, the number of connections. We can talk about the diversity, because scale here is about diversity. We can talk about diversity in terms of performance. If you look at latency and power consumption and bandwidth and so on, you can have a sensor that sends a reading once a week, or you can have something in industrial robotics that actually sends data all the time. So the number of data sources and the data rates are going to be very diverse. The costs are also going to be, very diverse, or the requirements on cost. And the cost is not only for the device itself, but the total cost of ownership of a solution, for instance. And also lifetimes is something that we need to keep in mind. Usually when we have mobile phones, we switch a mobile phone every 1, 2, 3 years, depending on how old you are. The younger you are, the more often you switch your mobile. But in IoT, you embed stuff in operational technology, and these things will be around for 10, 15, 20, 30 years, depending on sector. So how do you manage that? Now, that's on the number side. Then we have the qualitative aspects of things. It is technology fragmentation. There is technology fragmentation in IoT, because it's not a new phenomenon to connect things and automate things. It has been around for decades. But we're doing it with using new technologies now. So there's always going to be the problem of brownfield and technologies that have been growing and evolving in different industry sectors. How do we handle that? How do we handle the functional diversity? Depending on the use cases, we need different functions, different types of functions to solve different types of problems. The number of vertical segments is going to be is very wide, and looking at the different applications, they're very, very rich, and I will get back to that towards the end. And also manageability, because with personal devices, you can handle them yourselves. But when you embed stuff in a bridge or somewhere in a structure, you cannot reach it. A human cannot reach it. So these are different things that we need to handle when we scale. IoT, we all know this. IoT is not a single technology. It's a stack of technology. You connect devices. You have connectivity. You use some sort of computing, not only data center, but also edge computing is going to be very important for many of the IoT use cases. And then machine intelligence as a combination of AI and machine learning. And then everything needs to be secured. So in all of these different areas, there are different aspects that actually relate to scalability. And I will talk about 3.5 of these ones. I will talk about devices that actually has an element of security in it. I will talk a bit about connectivity. And I will also talk about how do we handle this use case diversity and driving solutions towards replicability of solutions, moving away from bespoke solutions. So the first one, billions and billions of devices. Really, how do you handle the scale here? If you look at IoT devices today, some of the current issues are summarized here. First thing is that the example taken here is from the consumer space. You buy one device and it's made for one application. And that application on your mobile phone, you need an app for that one. There's no interoperability. So they are, kind of device application silos. Problem number one. Problem number two, I mentioned, lack of interoperability. There are too many standards around. So we have invented a new one, of course. But there are too many, the lack of interoperability is really holding back, and that is one of the two biggest problems in IoT. The other one is security. And the third thing that is really a problem here, that is this thing around manual provisioning. You have to do everything manually. You have to pair things and when you connect and provision. We need to automate all of this. And how do we do that? So first of all, solving interoperability, what we say, we have been doing work for over 10 years in this space. And when I was out speaking like 6, 7, 8 years to OT companies and so on about IoT, telling them what this phenomenon is about, etc., they said, no, IP, we cannot use IP. It's too costly, it's too heavy, it's too power consuming, it is not secure, etc., etc., etc. That was the first barrier. But that barrier has actually been removed since then. So there are still some pockets of resistance, but IP is widely accepted that, yes, it's going to be IP for IoT, which is by definition. But what we have been, the next barrier that we have been pushing a bit is, let's use the standard web, the way that you actually run the web today. We had the keynote yesterday, Anja, talking about the majority of traffic, even though you had this peak around BitTorrent and peer-to-peer, it fell back to HTTP and RESTful being the dominating traffic type on the internet. We argue that, yeah, you can use standard web technologies for IoT. The way that you program the REST APIs, how you expose web resources, etc. Just a copycat into the IoT domain. But we need to make sure that actually fits the constrained environments when we talk about 32-bit microcontrollers. We cannot have verbose and long encodings, etc. We need to have it more compact. And this has been happening in the last couple of years. And the industry momentum in acceptance of this is actually growing and growing and growing. It has been a bit of a pushback. People are still a little bit in the different industries talking about their own, protocols like in building automation. You have KNX and Lonworks and X10 and what have you, Zigbee and so on. But they're more and more moving in this direction. And the last thing that we want to do is actually go simple. When I talked about these kind of device application silos, that the application devices are built for one single application. We want to break that and make sure that the devices themselves only expose the raw capabilities or the atomic sensing and actuation capabilities that they actually host instead of pushing the application down to the device. So here it's really what are the different resources and how do we expose them? And here we talk about semantic interoperability as a key thing. And I think my colleague Badri will actually talk about that in a presentation tomorrow on semantics for IoT. So you can come and listen to that, what that means. But that is really how you expose the resources on top. So this is what we have been doing. But this is just, let's say, that was the protocol stack. But if you look at integrating devices, there is a different set of capabilities that you need to have in the same kind of solution to actually make it work in a scalable fashion. You have the problem of how you actually bootstrap the device, including then the security and how you do the initial provisioning. How do you do firmware updates completely remotely and do remote management, changes to settings, etc. And also fault management and all of these different functions. And also supporting applications on top of it, exposure of capabilities and even having some sort of lower level programmability on these different devices. If you look around at the existing technologies today, they target some of these aspects, but there is actually, and some of them are covering many of them, but they are typically bespoke for a specific industry vertical. And that is what we are trying to get away from. To make the market really big for this. So there's a lot of stuff going on, but it's all proprietary. If you look at MQTT, for instance, as a protocol, it gives you a way to efficiently push data back and forth. You have the tokens to actually encode data, but nothing of that is standardized in an open way. And how you do the lifecycle management and bootstrapping, nothing of that is standardized. So everything is bespoke. So you should forget about, it's going to be MQTT or a single protocol. You need to look at the lifecycle management solution. And that is what we have been working on and being standardized, building on what has been developed in the IETF, taking RESTful environments into constrained environments with a protocol like CoAP and how you do the web resources that I talked about and so on, and also adding security. And this is a model, this is a framework that actually supports all of the lifecycle management that I mentioned in the previous slide. In device management, application support, it has built-in support for semantics and encoding of data, everything openly standardized. So looking at the organizations like IETF doing the basic building blocks and the context being done by IPSO Alliance and now in Open Mobile Alliance. As a standard called lightweight M2M. It should have been lightweight IoT these days. M2M is dead as a term. But it has all of these different capabilities that they need. And there is no other solution in the market that actually has that. I also, and one of the proof points I needed, we discovered, we had not been talking to IKEA about this, but IKEA is a company that do things at scale. And they have actually picked up on this, and they are using co-op, and they're using the IPSO objects for semantic interoperability in their home lighting product series. So light bulbs and switches, etc. So they picked up on that, and they realized that this is good technology, not doing Zigbee, not doing Z-Wave and other things, but actually picking up on doing this. Just a fun thing. The next thing that actually needs to be solved is related to security. And security, at the core of security, it's the identities, the credentials for securing things. But what are you actually securing? Well, you need security for different purposes in IoT and in general. You want to secure connectivity. You want to secure application data. But there are different stakeholders that deal with connectivity and that deal with application data, and they don't want to talk to each other. So you need different secure identities to handle this. So what we're looking at is not going to be, we have the same code that secures everything or anything like that, but we need to have a number of different secure identities. And you need to have them actually added and removed throughout the lifetime of a deployment. So that is something that we have been, or are actually working with as well. And it's really the life cycle, if you look at the device, it's from the manufacturer of the chip, the silicon. That is the first point where you can actually install credentials of silicon. And that's what we call root of trust. Now, once you have that, you can actually have that as an anchor point to add and remove other credentials if you build a framework around that. And we are working together with ARM and Intel on this. Intel, they have a concept called SDO, and ARM announced Pelion lately, and Intel is now also joining the Pelion initiative, and we are part of doing that. That actually secures that from the chip, then the chip goes to the device manufacturer, and the device manufacturer can sell it further to a systems integrator that builds a solution and that then deploys it and then switches it on and then bootstraps and everything. And all of these different points is where you actually want to add an identity or actually revoke an identity because of change of ownership or for other reasons. And when you, after 15 years, decommission the device, you remove or revoke the identity so that it cannot be misused later on. All of this entire process needs to be automated. This is not in place today. And this is, I think, and I argue actually that solving security, that is the hardest nut to crack, because the rest of automating all of this is going to be simple. But this means, and this is, the technologies for doing this in actually having secure environments and to provision security credentials and so on, the technologies are there. It's actually only about establishing this kind of best practice in the marketplace. So it's a combination of different ecosystems that need to get together to solve this jointly. I talked about lightweight M2M as an example of what we are promoting as, let's say, the way of doing the web to IoT. But of course, we have this issue with brownfield, and this is something that we need to address as well, because you have all of these other protocols as well. So what we have done and we are continuing to work on is actually integrating these different technologies into the same kind of framework. So if we look at lightweight M2M to solve the bootstrapping and the security, etc., how can we use that kind of framework and actually add just like MQTT is just going to be the data ingest type of protocol under the same framework. So we have already done this, and now we are looking at pushing this out into standardization. So moving away from the kind of bespoke ways of doing, connecting MQTT devices and doing it in an openly standardized way. So that was about devices and a bit about security. Of course, coming from Ericsson, I need to talk about networking, which is something that is not on my agenda actually, because I've never been, well, I did networking in the past, but not these days. Of course, I think that this has been discussed already here, so it's going to be quick. So 5G is, of course, something that we are pushing hard, and now it is rolling out in the market. If you look at the evolution here, going from 2G, 3G, 4G, what we did in those generations was to increase throughput by a factor of 10 per generation and reduce latency by a factor of 10 per generation. We are going to do the same thing for 5G. But we're going to do one more thing for 5G. We're going to make it IoT ready for the vast diversity of requirements. So for me, the real innovation with 5G is really IoT. It's not, mobile broadband on steroids. It's going to deliver that one as well. But it's really IoT to handle these different types of use cases. And the 5G approach for this is basically looking at two different extremes of requirements. One is around massive MTC, these tiny sensor devices that tick off data once in a while that should be deployed for many, many years. Very relaxed requirements. And then on the other side, you have the critical IoT use cases with factory automation, for instance, and robotics. So these are the two areas. And just looking at some of the requirements that are up for 5G, I will not go through this, obviously. But related to IoT, if you look at battery life, 10 years on AA batteries, that is what we are targeting for specific use cases. Something that was not possible in 2G or 3G, but now we have done that in 5G or in 4G, I should say, actually. So just give an example of some of the requirements, and also coverage, that we increase coverage so that you can go deeper into basements where you might have smart meters and so on. So these are some of the extensions that we're doing on cellular technologies. And 5G is not just a new radio technology. Of course, 5G new radio, NR, that is a new radio that goes up in the 60 gigahertz and so on bands. But it's also an evolution of 4G technology, evolving LTE towards this low end of capabilities. So 5G is, for us, it's a systems concept. It's an integration of 3G, 4G, and the 5G radio. And it also includes that we're going to be virtualizing the entire network infrastructure, which means that there will be distributed cloud computing capabilities. So if we're talking about edge computing, that means that you can take your IoT workloads and not only have it either in the data center or at the device, but anywhere in between in the network infrastructure. So that is what 5G is going to be bringing as well. And there's a tiny, tiny thing that I've added here, and that is called CapNet. Because as I mentioned, not everything will be connected using cellular technology. The majority of IoT connections will be using non-cellular technology. How do we integrate those technologies? We call them capillary networks. We integrate them as well. And the integration here, it's simple if you just want to shuffle bits and bytes from A to B through the infrastructure. But how do you actually integrate it from a connectivity management perspective, from a security perspective? These are the things that we need to integrate into the infrastructure. So there's going to be one network that can serve any industry, basically. And with even local deployments, LTE deployments on the factory floor, and even using unlicensed spectrum. So this is what we're looking at when it comes to connectivity for 5G. Now, I should also mention that we are not only doing this like in the labs, but we are doing this in joint partnerships. So we are running a number of different trial activities on making use of this in a number of different industries. Automotive and transport with connected cars, platooning trucks, and remotely operated cars that in real time you have haptic feedback and you can drive a car remotely. You can sit in the office and drive a car. So these kind of things we are working on, and also in manufacturing to have flexible robotics and distributed cloud capabilities on factory floor, connecting using LTE technology and 5G technology. So we are having a number of collaborations and proof points, and if you go to Ericsson.com, you can read more about what we are doing and many of the insights, because we need to do this reality check and learn what are the requirements and so on, and make sure that we do the right things in our development, research and development. So that was about connectivity. The last thing that I wanted to talk about is value-creating solutions. I mentioned, you know, the applications are very vast and wide. And just as a fun introduction picture here, you know, the layman view of IoT is basically either it's, you know, the connected and the smart home, or it is wearables. From an industrial perspective, it's all about predictive maintenance, because that is the talk on town. We heard the previous presentation talking about predictive maintenance, and it is one of the key use cases that we see today. And of course, we have autonomous vehicles. So these are the two ones that are being talked about in an industrial context. But if you look at the different sectors and that we see will be benefiting from IoT, and if you look at the different applications, there is, you know, a much wider spectrum. So the question here is, you know, I mean, the practice today is that you're usually building a solution. You look at, oh, this is the problem that I have, and now I need to build a solution for solving this problem. And that means that people are building bespoke solutions, vertically integrated, systems integrated, oriented projects to build solutions that focus on this point problem. And then when you move to the next problem or the next customer, you have to look at the specifics here, and then you start all over again, a little bit like this. So the replicability and reusability, the level of that is pretty low if you have a systems integrated approach. So what we are trying to do, and this is like work in progress for us, is how do we find reusability and how do we find replicability in solutions? How can we come up with blueprints that can be applied across? I already mentioned that about replicability and reusability. So what we have been doing is looking at, this is typically how people look at the taxonomy of different use cases in different industries. You have different sectors that contain different verticals, and then you have a number of different applications. So in healthcare, you might have hospitals, you might have personal healthcare as a vertical, and then you have specific applications like heart rate monitoring, etc. And that is where people stop, looking at this is the application, now I build the solution to target that specific application. But what we have been looking at is going through about 100 different use cases from across a number of different sectors, trying to extract what are recurring patterns. The same way as you build a system architecture, you look for recurring patterns. So we have been doing the same thing around these different use cases and identifying what we call these use case patterns. And basically, 7 major families of recurring things. I think Gautam also mentioned, you know, if it's the health of a car engine, or if it's the health of the heart of the patient, from an analytics perspective, it's the same problem. And that is exactly the same kind of thing that we're looking at, but doing this in a bit broader scale, trying to capture as many of the different IoT applications and use cases as possible. And looking at these different use cases, you know, depending on the problem that you're looking at solving, there are different capabilities that we need. Asset management, predictive maintenance, you need to analyze data on the fly. But if you look at, you know, massive monitoring that we call it, if you're looking at environmental monitoring or monitoring seismic activities, it's something that you do over time, and you can do offline bulk data analytics to do some forecasting and stuff. So depending on, and if you look at robotics, then you have these control loops in real time. And it's not like handling big chunks of data. In robotics, you know, a single bit can be very important that actually makes you take an action. So depending on these different use cases, you need to have different functional capabilities. And of course, we are looking as well at AI and machine learning as the big toolbox to actually solve that, but also adding them, you know, you need to have these expert system or rule-based systems. You need to still have control systems like PID controllers, etc. Depending on the problem, you need to have the right tool. You can solve many things with you know, using machine learning, but there are already existing tools. And if you're looking at thermodynamic system, I would rather use you know, the laws of physics to control that system rather than using AI that might fail and be wrong. So This is what we're looking at, these replicable solutions. How can we find high-level blueprints that actually solve these, that are generic and let's say, industry sector independent, that solves 80%, it's a solution that actually provides 80% of the solution. And then it's a matter of making that domain specific. I will skip through the different tools that we have. Just finish off by a simple example that we have been working on. One is around smart logistics, shipment of goods from A to B, and how do you actually plan and organize that, and how do you actually monitor the goods that is being transported. You need to track it, you need to trace it, and you need to monitor that it's being handled in a specific way. The other example is predictive maintenance that was talked about. Prevent unexpected machine outage, or if it's a tool that is wearing out, you need to know when to exchange the tool. You need to do that so that it disrupts the process at minimum, so you need to keep track of how it fits the production plan, the supply chain of tools and spare parts, the service technician that needs to service the machine. All of this needs to be, and also even actually changing the production process in terms of slowing down speed so that you can match the window of replacement at a specific point in time. Two very diverse problems. But we have been looking at, and this is work in progress as well, how can we apply, what are the different components where you can build these solutions, and how you actually orchestrate them in a different way to realize these different solutions, but still using the same type of abstracted components. So on the left-hand side, you have this thing around smart logistics where you create the contract. We are using smart contracts here based on blockchain technology. How you plan and execute the distribution, how you do the monitoring of the goods that is being transported, how you can actually do replan if goods is being spoiled or if a truck is stuck in traffic, etc. Doing complete replanning. Then, if you look at predictive maintenance, the order and how you actually connect these different and orchestrate these different capabilities is going to be different. But the capabilities are more or less the same. So, with that, I want to end and go back a little bit to, this is what I talked about, I hope, around what is scale and what, giving some examples of how we have been addressing these different diversities. And that is what I had on my summary slide. And I will also end by a short announcement that we just in December released the second edition of our IoT book. It's a comprehensive book that covers IoT use cases, technologies, architectures, best practices, and so on. It's also used as a textbook in some university courses. So with that, I would like to end. Thank you very much.
My question is simple. When you talk about interoperability, okay, the basic market fragmented is because of lack of interoperability. Lack of interoperability.
Yes.
And that's where standards come in.
Yes.
And when the stack you showed, it still does not ensure end-to-end device-level interoperability. Semantics, you said semantics are a very, very important part.
Yeah.
But somehow, the ecosystems are fragmented even
Yes.
for semantics. There are multiple SDOs.
Yes.
Every protocol defines their own semantics.
Yes.
So is there some kind of a
Yes.
holistic
Yes.
work going on standardization for semantics? And it is beyond IoT, because the devices are devices. They may be used in IoT use case or maybe infrastructure use case or whichever. Why do we have to change the semantics when we move from the use case to?
I mean, interoperability is something that you're pushing the problem of interoperability one step up in the stack all the time. We see this before. As I mentioned, we didn't have IP. Now everybody's converging on IP. Now we are pushing web, and some big players are pushing web and RESTful, and we see that it's actually moving in that direction. We are working now on semantics, and Badri will cover much of the semantics in his presentation tomorrow, so you should attend that one. I think the semantics is semantics of data is the next level of interoperability that needs to be solved. Now, I agree that each sector, they have been doing their own technologies across the entire stack. But I think that over the years, the awareness of everybody coming together to solve this is growing. So there has been a number of, let's say, bigger workshops arranged. There's in IETF, there's something called WishyWork. We arranged in the IETF Architecture Board a couple of years ago, widely attended workshop on interoperability. We have dialogues with OT companies that have come to us and looked at, okay, you have been doing this. We have this old IEC specification of substation automation. We would like to take that model into the same kind of, that legacy model, and translate that into what you have been doing. So I see that there's a number of these different openings that people are much wider in looking out there and actually trying to address this problem.
Still the problem that people are trying to address is still at the top level. What they're trying to do, you were using at the base level these semantics, here, there, and different everyone. Now let's have some interworking this thing, some common information model, some common data model at the top level. But the real problem has been that who is the rightful owner of the semantics, the products, the sensors, the devices, not the protocols. And unfortunately, protocols have controlled the semantics. You change a protocol, semantic change.
Yeah, but that's where we argue for a completely decoupling of that.
So in India, we are trying to come up with a holistic framework for defining the semantics for the devices, particularly right now focus on the smart infrastructure domain, but where IoT is all covered mostly, so that they will remain as part of the firmware, basic firmware of the product design.
So in the interest of time, can we take this offline? Yeah. So Rajiv has a question.
Yeah, hi, Jan, both you and Dr. Gautam Shah spoke about automation, and I think that's critical as we go forward in the IoT and industrial IoT systems. But it seems to me that automation will also come with a price, and one price could be cybersecurity. We'll have to even, and I'd like to know your views. There would be significant non-negligible vulnerabilities as you have more and more automation from the point of view of security. Any comments on that? Thanks.
I mean, one aspect of this is, I don't know if it's related to cybersecurity, but what we need to have are safe systems. It's one thing that you actually have a system that is working on solving or automating a particular task. But how do we make sure, and how do we make sure that it does it the right way? So it's this kind of adaptive feedback that basically one could view it as you have a system that is monitoring how well the system is actually performing the task in order to actually make the system more reliable and safer. Now, cybersecurity, I mean, security in IoT is, it's really a big issue. I mean, cybersecurity on the internet today is, it's social reputation that can be damaged, or you can lose money. In IoT, it's a completely different ballgame, because people can get killed, and property can be destroyed and stuff like that. So
in the interest of time, we'll take one more question.
So I didn't read, but we can talk later. I will be around, by the way, so
hello,
the entire day.
I'm Manjesh from IIT Bombay. So my question is related to this 5G network. So as I said, in 5G network, there'll be both cellular component and non-cellular component, and IoT is probably falling in the non-cellular component. So where they have to, many of the devices has to make a decision on their own in a distributed fashion. So there will be, in that case, there will be some self-organization and self-learning. So do you see what kind of AI and ML technology playing roles in there, and is there any standardization going through in this aspect, especially what kind of AI ML technologies are appropriate?
Yeah, I heard two questions. Let me try to be brief. The first one was around IoT is not about the non-cellular component in 5G. IoT is supported by the cellular components of IoT as well. But time-sensitive networking will not happen over the air, the synchronization, etc. So it needs to be complemented, but it needs to be well integrated into the infrastructure. So that was number one. Number two was, what's the role of machine learning in these type of network? It's a critical component to actually manage the resources we are talking about self-organizing networks, and you had that question in the previous keynote. It's a key component for operating the network and running the network as such. And I don't know if we have anybody here that can actually handle that question, those kind of questions in more detail if you're interested. But it's critical, absolutely.
Okay, thank you very much, Jan. So we have a small token of appreciation for you. So I would request Dr. Manish Gupta, CEO VideoKen, to please come and do the honor. So Manish actually needs no introduction. So he's presently also the Infosys Foundation Chair Professor, and he has held various important positions, Director